Hello and welcome to this lecture on applied ergonomics, lecture 8. We were talking about the various ways and techniques of recording the facts that you get out of some identified process or task or a job in general, and it is basically only related to or limited to an organized representation of all these in terms of symbols or arrows or flow or diagrams, so that you get an overall perspective at a very short glance about how the process would really look like. That is only purpose of laying this out. And then we also did some time motion studies, where we talked about time studies, where we talked about what is the normal time and what is the standard time with an allowance factor included inside. We did some numerical problems as well. So today we will be looking at how these time studies affect particularly sequential operations related to assembly lines, etc. And for that I have the following example here. For example, let us say we have an assembly line which has a number of workers, about 8 workers here, and there are 8 stations on this particular assembly line. Okay, so we have 8 stations in an assembly line, and we have through any of these approaches, including the stopwatch approach or the cycle graph or chronocycle graph, we have been able to record the times of individual operators on such an assembly line. So let us say the cycle time, which is corresponding to the work delivered by an operator in one particular station. So these are 8 different stations, and each station has a certain cycle time associated with it, meaning thereby that whatever operations are intended to be done by the single operator on one particular station are about there are 8 such operation domains, or let us say operation subsets, which would together integrate out to be the whole task on the assembly line. So the first worker has a cycle time of 30 time units, the second has 26, third has 28, fourth has 26, so on and so forth, and this comes out of the regular observation through stopwatch or even some of these other techniques, you know, where using microfilming motion you could accurately predict or estimate what is the kind of time involvement in such operations. And here you are seeing that for all these different 8 stations which are there, there are close to 8 almost different times which are associated, and the highest time that this operator right here, operator number 6, takes on his particular station is 32 seconds. So this is determinant of the overall cycle time of the overall cycle time of the assembly line, okay, because obviously the slowest step is the limiting step, because that is the maximum time requirement. So the line has to run or operate only looking at the slowest operator or the slowest worker. So this is the situation. Given this situation, if I wanted to look at what is the productivity of this particular line, so we know that about 32 seconds is the cycle time, okay, of the line, because if you move it more than 32 seconds, then this operator here is not going to do its job completely and the assembly would be disbalanced, okay, or the line would be disbalanced. So the production per hour really is at, let us say, 8 stations, 32 seconds together. So the per hour production would be about close to 112 units, as has been represented here. And what we can do now is try to split up individual tasks and try to recombine different tasks, so that overall this time level kind of comes to a certain minimal value. So we do this with time and motion studies, and we try to balance the operation, and after a time study and line balancing, we see that now the new time scales which emerge on all these 8 stations have maximum time of about 28 seconds of almost all the operators. This can be done only by virtue of some task adjustments between these stations. So one operator who is probably doing more tasks, obviously there are 2 aspects. One is what is the operator performance, and another is what is the operator cycle time, and these operator performance etc. has been taken care in your standard times which you have plotted in the time study sequence. So here the aspect is about how to redistribute the task among the different members, so that the overall level goes down to certain basic minimum level. Here it is 28 seconds, for example. So obviously the productivity has increased because of this, because now in 1 hour you can produce 128 units, which is about 16 units more than what you produced before. So it is about a 5% increase only by virtue of time study and line balancing that you have done in this particular case. So that is the basic concept of line balancing. So you adjust your tasks in a manner so that overall the slowest step of the assembly line, or let us say we can call the highest cycle time step, of the assembly line is shortened back, and there is always almost a leveling of all the workstations in terms of time scales, so that you can actually now predict what is going to be the maximum production rate this way, and this way the production rate can increase by cutting down all the slacks. So, essentially what you are doing is, by balancing the line properly, you are working on cutting down slacks for this guy or this guy who have finished the tasks earlier. Okay. So, they are actually waiting till this guy accumulates the or accomplishes the task. So, this waiting time is being slacked, which is not a problem, because you want the operator to work at full productivity. Okay. And so is the case with machines as well. So, obviously machines are more presettable, and there are no psychological issues associated with machines. So, you have lesser degree of let us say controlling situations. Okay. But in case of operator driven assembly and all, there is a big psyche issue which comes into picture, where there is complete lack of control, and a lot of controlling needs to be done. So, what really makes you decide why you want to do what you want to do in terms of motion and time study? So, the first thing that we look at the first thing we look at is basically, is the production cost too high? Is it something that is going to be a problem, because you are selling in a market at a fixed price and your cost comes out to be too high, so your profit margins shrink because of that. So, then you look at, if really this is the case and the production cost is high, so can I actually identify why is there a problem, why is there a high production cost? Is it because the utilization of the system that we have at hand is not effective? Are we not optimizing the work system that is producing? So, this is something that we have to first look at. Then we think about how to solve it. So, now you basically split it up into various smaller groups of tasks and activities and associate time scales, and then try to see, by proposing some alternatives where there are slacks, which alternative would be better. So, you redesign things so that your overall time scales go down. You just saw the case of assembly line before, how you could manage with a higher productivity at a certain point, and there are several such lines into place when we talk about a big production system or a big work system. So, obviously all those slacks need to be removed. So, there are different alternatives that you would assume by redistribution of the tasks, or by more balanced approach in continuing something or carrying out something, so that there is a best alternative which emerges. Okay. And then that you implement, and then you find out whether you are actually getting a lower production cost because of all this time and motion studies. So, that is what is the algorithm that you follow if you want to decide why you want to do a time and motion study. So far we have covered these two tasks. One is identify the job task process, another is recording of the facts in an organized manner. The third thing which remains is a critical examination now, because once you have recorded information as in step 2, you need to look at that recorded information and try to take some decisions and suggest some alternatives, so that there is a change in the overall operating parameters. Okay, so that you have optimization carried out. So, in critical examination step, you basically look at all the recorded facts, which are there in terms of flow process charts or different other representations that I have told you so far, and you critically examine them, okay, all these facts. So, you have to apply a sort of a questioning technique to yourself, which involves the following sequence. So, first of all, looking at particular set of activities or a task, you want to just define the basic purpose. So, we have to identify what is the reason why the activity is done in a manner that it is done. Okay. So, the basic purpose for the activity is first question. So, you record that, but then you talk about the place. Okay. So, if this activity has a purpose which is contributing to the overall work systems dynamics, then we have to now record what is the place at which this work would be carried out. Okay. So, place for which this activity is done, at which this activity is done. Then we talk about the sequence, meaning thereby that probably this is an activity which comes either later down in the sequence of activities, or even earlier on in the sequence of activities, which are all carried out in order to meet a goal which is the output of the concerned work system. So, what is the sequence? What is the let us say start point or end point of certain activity in the domain of all these activities placed in a sequential manner? Now, that is something which we need to then understand well. And then we talk about a person. Okay, so, we associate with this particular activity somebody who does this activity or does this task or accomplishes this. So, this is the person or the worker. by whom this activity is carried out or is done. Okay. So, we associate where exactly, so there is a purposeful activity which is there at a certain place in certain sequence with respect to the other activities done by whom is sort of addressed so far, and then you talk about the means that the person uses by which this activity is carried out. For example, it may be loading and unloading of a material box from a truck which may be done by a forklift. So, you are using the means which is the forklift by the person who is doing the loading unloading, and that is probably at some kind of a dockyard where this this container or this part is stored. Okay. So, the place is defined, the purpose is defined, the sequence in which it has to be loaded and unloaded is defined, the person by whom it is being done is also identified, and then you are doing the means. So, you means is by using a forklift, for example, or a crane or a gantry system, for example. Okay. So, so these are some of the basic questions that you need to address, and these are also done in with the objective, the overall objective of eliminating, combining, rearranging or simplifying, okay, the overall activities. It may be it may be very much imperative that you are doing an activity which could otherwise have been combined with something else, and it would need not be carried out. Okay, it need not be carried out if there is a combinatorial with something else. So, you basically try to now look at each activity and a sequence of activities in a manner, so that can we combine two activities together, or can we probably rearrange the activities so that something does not need to happen. For example, you were carrying out an inspection step prior to, let us say, machining operation A, and then again let us say machining operation B. So, rather than that, if we carry out the inspection step, if it is possible, after A and B is over, after machining A and machining B has been done, to the overall totality of this part, if it is doable, then we better combine it. Okay. So, those kind of decisions has to be arrived at in your questioning technique. Okay. So, you do this multiple times, question yourself every time about the activity sequence, and such questions could either be primary or secondary in nature, which are basically what are those primary questions. So, let us see, when we do this, we are trying to now go to the purpose, for example, and trying to question what is actually being done. Okay, what exactly is the activity about, okay, and why is it really necessary at all. So, if it is not necessary, it could be eliminated at this stage. So, if it is not necessary, eliminate, otherwise proceed. Okay. So, that is a purpose based question. Now, it talks about a place based question, where it is being done and why it is being done at a place. Can we have a different place where this activity could be done, so that there is less movement of material or less movement of, let us say, workers between the stations. And so, basically when we talk about this place based, and in combination of that, we talk about sequence based, which talks about when it is being done, why at that particular time, can it be done earlier in time or later in time. So, some things like this which would give you an idea of why the sequence of the activity is there, and the person who is doing it, or why this particular person is doing it, can it be done by another person who was doing another job. So, these kind of questions you sort of combine together to take a decision whether the activity really can be combined or rearranged. So, some of the activities are eliminated which are not necessary, and some of the activities which are necessary and they have to be a part of the system can be combined and rearranged by these set of questions. And then finally, we talk about the means by which this activity is being carried out, where we again address a basic primary question, is that how the activity is being carried out. Okay, what is the exact tool or what is the exact system which is being used for carrying out this particular activity, and why it is done in a particular way, why not a different way. So, if supposing you have combined, rearranged and gotten to a point where no further combination or rearrangement or relocation or elimination is possible, this is the sort of minimum activity sequence which is needed for accomplishing of a certain task. Okay. So, once that is happening, then we talk about how to simplify it. So, basically, if something comes here saying that okay, the means that is being done may not be a very good way, because it could be possible if I involve a machine tool there, I am able to get this job done much quicker, or let us say with more accuracy. So, we can simplify some of the means itself, so that you have the activity is now well balanced. So, these are the primary questions which anybody would ask in order to look at a chart and look at what is important, what is not important, what can be combined, what can be rearranged, and how it can be simplified. These are the things which you are sort of addressing. The secondary questions come when we talk about corresponding to each answer obtained through the primary questions. you could raise some questions which can explore about the possible alternatives. So, it may be possible that in somebody's mind through the primary question something comes where there is an alternative of combination. Just I just mentioned about combination of two different inspection stations, or let us say two different inspection routes which are possible after machining A and after machining B individually, or combining machining A and B together and then inspecting the whole machine part. Okay. So, this is an alternative, that you are combining all the machining systems together, so that you are getting a part where there are remnants because of A, remnants because of B, which you can inspect together. If possible, if such a thing is possible, you try to combine and try to do inspection at one particular step. So, that is the generated alternative. So, these kind of questions of primary nature, whenever you ask, at the back of the mind you have to always see why not in this particular manner, or why not using this particular alternative. So, once this comes, the alternate purpose, the alternate place, the alternate sequence, the alternate person and means, then the methodology sort of gives you an idea about how you can control, you know, the sequence of activities in a manner as follows. You will particularly ask what else might be done, okay, what else might it be done, what else might do it, who else, or how else might it be done, or who else would do it. So, these kind of questions would kind of give you the alternatives. Okay. So, these are all the different alternatives which you have in mind while doing or posing yourself the primary questions, and these alternatives are very important, because mind you, when we are doing a process improvement, when we are doing a improvement in the overall optimization by virtue of time and motion studies, it is about those alternatives which you suggest, so that you have overall betterment of the work system in terms of its productivity. The whole framework is how you could improve the output input ratio, and so therefore, this question of what is an alternative solution which is probably better off than what solution exists is very important for a person to sort of you know, get a feel of how to redesign the particular work system. Okay. So, by answering the primary and secondary questions, we use a systemic critical examination in order to evolve a better method of doing the work, and that is exactly what you want to implement, okay, and see what is the outcome or what is the result. So, let me now change gears a little bit and look at what is the workability mode of such work systems, and what are the kind of classifications which are available for such work systems. So, typically a work system could have a component of manual work, and it could also be classified as a worker machine system or a completely automated system. Okay. So, these are the three different classifications, broad classifications into which we could actually put or lay out all work systems. It could also be about, you know, let us say either a completely continuous flow process where you are having work continuously being done, value continuously being added to a product as it moves along from an input to an output stage, and alternatively there can be a batch processing where you have a lot by lot movement rather than one continuous movement where you are introducing component one by one. So, you have a batch processing by batch processing. That could be another way or another alternative of looking at a certain work system in terms of how it works. There could be manual assembly lines which you could look into. For example, let us say when we talk about again a car line, and when we talk about painted body storage, the painted body storage which actually goes into inspection and repair are basically done on trolleys. They are no longer on assembly line, and these trolleys are all chained together, and you could actually push those trolleys between the different inspection stations and repair stations, because particularly the associated problem with paint repair is that the time scales are not known. It may be dependent on the extent of damage that is there or the extent of defect that is there, and the time scales may be different. So, you can't put them on an assembly line by any chance, but then you could actually do a manual assembly line where you could actually move trolley by trolley and then try to analyze. So, that could also be a part or a variation or a deviation of a work system. There is of course logistics operations particularly related to material flow etc. associated with such work systems, based on also which we could classify. There could be a different form of a layout of the material flow in comparison to as a differentiating mark between different work systems. There can be service operations and office work, that is also a sort of, you know, associated modality with the overall workability of the work systems. And then of course there can be projects and project managements on a very broad scale, which could also be directly included into the way that a work system would function or work. So let us look at manual work and work machine systems. So you have again completely manual work systems where the worker could use either almost a manual approach or a slightly tool driven approach, where there are certain hand tools which could be used by the operator to work on different aspects of a work or a product. There could be worker machine systems, there could be automatic work systems. I think I just mentioned about it, fully automatic without the involvement of any human component. And here the idea would be that how do you determine the requirements of various people, including the worker and the machine requirements, and then you could have a system with such requirements clubbed together as clusters. For example, all the machining activities of one type could be clustered together, machining activities of another type would be clustered together. In this way you build batches of different kind of let us say machining elements, okay, which would be clustered together in a particular manner to build up a worker machine system. Okay, so let us look at these in a little more details, at least the first three in a little more details at this time. So when we talk about manual work systems, we are having worker performing one or more tasks without the aid of any powered tool typically. So as I told you that it could be either based on direct applications of hand in order to do the job, or sometimes some tools which could be used as aids for doing a particular job. So that could come over in a manual work system. We could also have a worker machine system where let us say the human worker operates with a powered equipment. For example, we are talking about using of a power saw or a power cutter or a power drill, or even in some cases a power hammer to work on concrete slabs or something like that, where there is a powered equipment which is available. So typically the difference between a manual work system and a worker machine system is that there is now the addition of power. Okay, so this makes the two systems completely different. So you have a powered machine tool along with a human subject. And then of course the third category of a work system is a completely automated work system, where we talk about a process performed without the direct participation of a human worker. For example, let us look at a transfer press. So typically in a transfer press system in an automobile line, it is a mechanical press system which is comprised of several workstations with different die pairs, where there are different operations including forming, punching, shearing done on those sheets to formulate a certain profile. For example, when we look at let us say the roof side or the roof panel is subjected to many such pressing operations which would be done through different die sets in a particular transfer line. Now once the loading of the pallet, which will typically be used for pickup of the sample, okay, which is like a sheet, a flat sheet or a blank you can call of a particular sheet metal is done, then beyond that you leave it onto the machine, how the machine picks up using vacuum assistance or vacuum assisted techniques, and then stations the particular panel into different dies, and between dies that does a transfer and does an inspection. So now it is no longer in the human domain, it has been completely taken over by CNC control or programming logic or probably the machine domain. So those kind of systems are called completely automated work systems. Okay, so there is a different class of things where there would be a different approach which is followed for doing associated tasks with these kind of work systems. Let us look at it in a little more schematic manner. So in a manual work system, you could have the starting work unit where you can process this using either just applying force on it or power on it or something through human subjects. So you have a worker who is working on a process, okay, and at the most he can use hand tools. So that could help this worker to realize this process, so that there is some kind of a completed work unit which goes out. So this is a what you call a complete manual work system. And then there is a worker machine system where you are having a worker working onto a machine which is powered, and it is basically running a process which is actually starting the work unit and completing it into a certain finished job. So you have this additional powered machine as an aid to the worker for this work machine system. And the automated system, of course, you have only a periodic attention, like for example in the transfer press line I mentioned, attention has to be given when something goes wrong, for example, or in terms of die maintenance. There is a schedule which is there where you look at a die and try to see how often this die can be polished, or whether the profile, the topology of the die has worn out. Okay, so there is some maintenance schedule where human subjects are involved, and then also there are times where in such cases, let us say there is a problem that the stacking has already been finished and you need to reload the material, or the stacking has been on the output side has been overfilled and you need to put an empty pallet there where the worker would be seeking or the attention of the worker would be sought. So, otherwise if these initial conditions are met, by and large the system is automatic itself, it takes care of all the things on its own, and so it starts the work unit on its own, executes the process and completes the work with an automated machine. So, that is an automated system. So, while we classify things into the manual, the worker machine and the automated systems, there are certain definitions which are useful, which we could actually think about referring to when we try to gauge some of these systems. So, the first definition is about work unit, which is the object that is processed by the work system. Okay, so, what can be called a work unit could be anything related to, let us say, a workpiece being machined for production work, or some material which is being moved for the logistics work, or some customer which is waiting in a store for a service work to do, or some product being designed which is a knowledge work to do. So, these are all different forms of work unit which could exist in such a work system. And the other issue which is important for me to tell is the unit operations, which talks about the tasks, the processes that are treated as being independent of other work activities. Okay, so, these are some units which are actually not the work unit, but various things which you do to the work unit in order to complete or let us say finish the particular process. So, having said that, we will look probably into the manual work systems and how they are defined and how work units and unit operations can be classified or measured in such system, but we will do that in probably the next lecture. So, we will finish this particular lecture. Thank you very much.